Hey, today we're going to be talking a little bit about the periodic table of elements and how this could help your student on the EOGs. Whenever your student is taking the 8th grade science EOG, they will receive a blank sheet of paper, of course, and then they'll also get a copy of their own periodic table. And we always encourage students to fill up the front of this periodic table with as much information as they can to help them with their EOGs. So today we're going to go over some strategies on how they will be able to do that. First thing we want to talk about is just basic setup of how the periodic table is arranged. We have two different categories called groups and periods. Groups are the vertical columns on the periodic table. They go up and down, and elements are arranged by similar properties. So they are in these vertical columns based off of similar characteristics. And as you can see, from these gray boxes, we have 18 groups on the periodic table. This first group is called the alkali metals. They are located in this group because they all share similar properties. If you look at their atomic structure, each of them only have one valence electron, which makes them extremely reactive. So we go from the most reactive on the left side of the periodic table, and we transition all the way over here to the 18th group, known as the noble gases, which is the least reactive group. So deactivity decreases from left to right going across the periodic table. Here in group 18, each of these elements are located in group 18 because they are the least reactive. They have completely filled valence shells. That means that each of their atomic structures, the shells are completely filled and they're not allowed to react with anybody else. So you might see a question on the EOG that says, which element might be located in the same group as potassium? And the reason that we are going to know the answer is they might ask boron, arsenic, or sodium. And we know the answer is going to be sodium because they are grouped by similar properties. So if they are in the same group, they share similar properties. Okay, so groups are vertical columns on the periodic table. They go up and down. Periods, which is our other category, they go horizontal. So they are horizontal rows on the periodic table. They go from left to right. Here is our first group, starting with hydrogen. There's only two elements, hydrogen and helium. That's period one. Here's period two. We have lithium all the way across to neon. We only have 8 elements in period two. Same goes for period three. Sodium across all the way to argon. Period four, straight across. We end up with 7 periods. So we have 7 horizontal rows on the periodic table. So groups are up and down columns. Periods are horizontal rows. The next thing that we want to talk about is the transition metals. We have the alkali metals, we have the noble gases, and each one of these groups have a family name. Numbers 3 through 12 right here are called the transition metals. Remember that. They are called the transition metals, and here in a second we will tell you why they are the transition metals. We have 3 different types of elements on the periodic table. We have metals, we have metalloids, and we have nonmetals. If you look at this dark stair step right here, the elements along the line right here are known as metalloids. Boron, silicon, germanium, arsenic, antimony, tellurium, and 85 astatine are all metalloids. So all of those elements, numbers 5, 14, 32, 33, 51, 52, and 85 are metalloids. Okay, so kind of remember this stair step as kind of a dividing factor. Everything to the left of that stair step are metals. So everything to the left of the stair step, we have potassium, titanium, iron, cobalt, nickel, copper, zinc. A lot of these all kind of sound like metals, platinum, gold, silver. You're able to tell that all of these are metals just by a lot of their names. Everything to the right here is nonmetals. So if you look at this stair step, everything that's not a metalloid, like we said, boron, silicon, numbers 32, 33, 51, 52, and 85, everything to the right is nonmetals. And the way that I tell my students to remember this is if you look to the right, helium, I always ask them, what is helium used for? And students always say to make balloons float. So I always ask them, would a balloon float if it had metal in it? And they all say no. So that's a good way for them to remember that to the right is the nonmetals. Also, we have oxygen over here. Everyone knows that we breathe in oxygen, so I always ask my students, do we breathe in metal? They all say no, so that's another way to remember that everything to the right is a non-metal. Next thing we kind of want to talk about is just each individual square right here. So we'll use helium as an example. The number at the top is known, it is known as the atomic number. These two little letters right here is known as the atomic symbol. Helium is the element name, and this number here at the bottom, that is the atomic mass. The atomic symbol right here, it tells us the number of protons and electrons. So if you have a question on a test that asks you how many electrons or how many protons does helium have, it's simple. You come and look right here at this number and it will tell you. Okay. Well, that just leaves us with neutrons. So how do we find the number of neutrons? We take the atomic mass right here at the bottom and we subtract the atomic symbol from it. So we got 4.003 minus 2, and we get 2.003 rounded to the nearest whole number, and we get 2. So we also have 2 neutrons as well. So you take this number and you subtract this number from it, and that gives you the number of neutrons. Next thing we want to talk about is just kind of the reactivity one more time, just to touch base on that. As we talked about earlier, this is the most reactive group. Group 1 is most reactive. So as we go from left to right, reactivity decreases all the way until group 18, and this is the noble gases, and they're not reactive at all. They have no reactivity to it at all. So that is kind of our basic review of the EOG. We'll be going over this more in class with the periodic tables as we go through review season. If you could just touch base with your students and go over this a little bit with them. Hopefully it will help them on their EOGs. And like I said, we always encourage our students, as soon as they get their periodic table and their blank sheet of paper, just write down as much information as they can on it. That way they clear a little bit of space in their brain and they can refer back to it while they're taking the test. Thank you.